Morning, everyone. I thought that we could quickly have a look at the worksheet that you did recently, calculating genetic variation. And I just thought I'd give a little bit of feedback on some of these answers. So I'll look at one answer, question 1 for 1C. I'll look at 2C. I'll look at question 3. And then I'll look at question 5. Most of these were done really well, so well done, and there are just a few pointers that I want to make, so this won't take long at all. Okay, so let's have a look at this. So I've just written out some of the answers, and I will share the mark scheme with you. So I think we just need to acknowledge that there's a difference between the two types of questions. So question 1 is just asking you how many combinations can be made in an individual gamete given that there are 15 pairs of chromosomes. So in one gamete, if you have 15 pairs of chromosomes, this is the number of chromosome combinations that you can have in one cell. Question 2 is different because it's talking about the combinations in the actual zygote. So that's if you have two gametes coming together. So you have an egg cell coming together with a sperm cell to form a zygote. Okay, so using the ideas from question 1, an egg has got 2 to the power of 23 combinations. A sperm has got the same number of combinations. So to work out the number of combinations in a zygote, we multiply those both together. So we end up with 2 to the power of 46, which is 7.04 times 10 to the power of 13. Please remember not to record every single number that your calculator gives you, and rather record two decimal places unless you are given some specific instructions about significant figures. Okay. Question 3. Oops, don't know what happened there. Question 3 is 5 pairs of chromosomes. So that will give you 32 possible combinations. But again, if you combine 2 of those gametes, so there's the egg, there's the sperm, if you combine them, you get 2 to the power of 10, which is 1024. And then in question 5, question 5A wanted you to work out the possible combinations, first for the horse, then for the donkey. So here's the horse, here's the donkey. 2n is the total number of chromosomes in a diploid cell. So if there are 64 chromosomes, that means there are 32 pairs of chromosomes. So in order to work out the possible number of combinations, it's 2 to the power of 32, which is 4.3 times 10 to the power of 9. Many of you did not write this number in standard form. Please write it in standard form. And again, could you please round off your numbers? Here they've rounded to 1 decimal place, round to 2 decimal places. That's absolutely fine, but do not report every single number that you have. You do the same for the donkey. The donkey has got 62 chromosomes. That means it's got 31 pairs, 2 to the power of 31. This is the number of possible combinations that the chromosomes can have. Okay. Then the last part of the question, which was the only one that I'd say most people struggled with, was that if the horse and the donkey mate with each other, how many possible combinations are there? Well, we multiply those two numbers together. So 4.3 times 10 to the power of 9 multiplied by 2.2 times 10 to the power of 9. So that would be 4.3 multiplied by 2.2, which is 9.46. 10 to the power of 9 multiplied by 10 to the power of 9 is 10 to the power of 18. And that's how many possible combinations there are in the offspring. Okay, so I hope that has helped with sorting out any problems you might have had with that. Just remember, write your big numbers in standard form and make sure that you report to a respectable number of decimal places.